Hello guys, Matt is back with another Typescript tutorial, and just like I promised yesterday that we'll be looking over the solution for the problem I gave to you, and in this video we'll be doing just that. And for all the new people, if you haven't already subscribed, please click on the subscription button below and don't forget to hit the bell so you get notified whenever I release new tutorials. Let's go. So yesterday, we had a chance to write a simple solution for removing even numbers from our array. But I mentioned it to you that this will actually not work for all cases of your array. So for us to be able to do that, we actually have to tweak the logic uh, a little bit. So I'm just gonna put the code that we made yesterday into a function so that we can look at the two approaches side by side. So I'll just uh, create that function here. Since this is not a foolproof solution, I'll just call it the naive solution, right? The naive solution. I'll call it the naive solution. Or maybe because since we're removing a legend, let me just call it the naive remove, right? Remove. So we want our naive remove method to take in an array of numbers. And then what should it do to that number? To those numbers? Well, it should do what we had last time. And then I'll just replace away all the references of numbers with array over here. So yeah, so I will remove that and I will remove that as well. I'll just explain to you why it won't always work. So I'm just gonna copy this. I have another screen on the side. Just copy this guy for you over here, and then I'll actually make another one. So we're reusing the range function we had from the previous video, which is there, which generates a list depending on the length of your n. So a list of, if you give it 5, it will give you numbers from 1 to 5. If you give it 10, numbers from 1 to 100 to 10, and so on and so forth, depending on how you use it. So we have this unordered list here, which also has numbers 1 to 10, but the order is jumbled up. So 8, 2, 3, 1, 9, 5, and that you can see it from there. So, and our ordered numbers is 1 to 10 in order. So let me just log that for you so you can see. I'll log not the unordered numbers, but actually the ordered numbers. I'll compile this quickly. Yeah, so as you can see, our ordered numbers is 1 to 10. So now let's so actually for our naive method should actually return this guy. Should return an array for us. So I'm going to return the array. Yeah. So let's run our naive remove on both these two and see if we get the right solution. So I will do this. So first of all, I'll log our ordered list. Let me do this. Boom. So first of all, I'll log these two. I'm just gonna just move it a bit. I'm just going to close this guy on the side just to give myself more space and drag this down to the bottom. So yeah, so we have that. So now let's run our naive method on both the arrays and see what we have left. So I'll run it from on there, and then I'll also run it again on that one, and then these two are before. So before, same thing there. So I'll just copy this to the bottom and just go after, and then I will just compile it quickly and then run it. So looking at these, we know before you're on ordered list, you saw it, it's just what we have here printed out to the screen, and before our ordered list is there 1 to 10. Now our unordered list is 2, has a 2, and has a 10. So you didn't actually remove all the entries of even numbers in our array. And same thing, but for the ordered list, it actually removed all of them. So if you're using an ordered list, you might think that the solution you had for in the naive remove was actually an optimal one or the correct one, really, but it's actually not. So let me explain why this does not work. So it doesn't work, firstly, because every time you remove a number from your array, the size of your array changes. So it's one less than the one you from the previous one. Let me use this unordered list to try and go through our algorithm over here. So when we start, I would be 0, right? And then that means num would be 8. So because at position 0 in our array, we have 8. So num would be 8, and is 8 divisible by 2? Yes. So it would remove 8 from our array. Now our array is no longer of length 10, but it's of length what? Length 9. And it has actually shifted. 2 is no longer in position 1, but 2 is now in position 0. But when your loop comes back, I would be 1. So you'd actually skip 2. So you'd actually move to 3, and then you would actually not evaluate 2, which would be in position 0 in the next run. So for us to be able to get the correct solution, we actually need to keep track of the number of things we remove and make sure that we look at the right index. So to be able to look at the right index, now I'm going to write another solution. So I'll call that correct remove, really. Correct remove. And so we said we need to keep track of the things we remove. So to start off with, we haven't removed anything. So since we haven't removed anything, our remove count, I'll call it the remove count. Remove count would be 0, right? And then now, every time we remove something from our array, we need to add 1 to the count. And we only remove something in an array in this piece of code here, in this if statement over here. So that means every time we're in here, we can actually just go remove count plus plus. I've already explained what that is. It actually just increases the value of remove count by 1. So every time we remove something, we'll actually increase the count by 1. But there's something else we need to do. We also need to make sure that we're using the right index. And how do we get the right index? So when you remove something, there's a shift, right? And that shift is actually it shifts by 1 every time we remove something from our array. So that means to get the right index, the right index that we should use, I'll call this IDX for index, should be I minus the count. That should be our right index. So, and we should not use I here, we should actually use index. And here we don't actually remove something at I, we actually remove it at our index. So to start off with now, let's just look at this. Before we run the code, let's just try to look at the logic ourselves and try to see if it's actually the correct one. Start off with, we'll have 8 at position 0, and then this would be what? In our IDX would be, I would be what? 0. Remove count would be 0 for the first time because we haven't actually come here. So it will be 0 minus 0, which is 0. And then now at position 0 of our array, we have 8. And 8 is divisible by 2. So we come here, remove the 8, and then add 1 to the count. And then when we come back for the second time, I will be 1. Remove count will also be 1 because we increased remove count by 1. So now it will be 1 minus 1. And since we removed 8, at position 0 we now have 2. And that means num will now be 2, and it's 2 divisible by 2. Yes, and we'll come here, remove the 2, and then our index now will be what? 2, and then we move forward. So this should actually be the right solution for us. We'll see. Let's see. So now instead of running the code on the naive remove, let's run on the correct remove, or so we think is what we think is the correct solution. So now I compile that, and then I run it again. So look at that. So for this one, our ordered list, we still actually have a problem over there. We have a 10 there, and then we have what? We also have another 10, a 10, and an 8. So we didn't actually remove everything. What might be wrong? One thing that's we should think about is this guy over here, because that guy changes with the length of our array changes every time we remove something. So when we start off with a list that's of length 10 and remove the first 2, we actually have this guy will be 8. So meaning we all won't actually look at the whole, won't actually continue up until 10. But we want to make sure that we exhaust the whole array. To do that, I'll cut that over here, and then I'll just create a length variable and make it that. So now looking at this, so this guy will not change. This guy will be the initial, let me call it initial length. Initial. So we need to run it for the initial length. So the initial length of our array would be 10, and this will not change. This only change after this for loop and within the context of the for loop. So by doing this, we are making sure that we take the initial length of our array. So I'll do that. I'll compile and then run it. So now we actually have the right solution for the question. So we have 1, 3, 5, 7, and 8, and then we have 3, 1, 9, 5, and 7, which is the solution that we're actually looking for in the previous array, from the previous video. Sorry. Try and engage me if you don't understand if you don't understand something from this video, and I'll be happy to explain it to you so that you are able to understand. So yeah.